So we're going to be talking about inverse matrices here, or more specifically, finding the inverse of a matrix. So inverses of matrices are pretty interesting because usually for the inverse of a normal number, the inverse of 7, all you do is just you put it in the denominator, or you divide 1 by that number, right? Right. So the inverse of 7 would be 1/7. The inverse of 1/2 would be 2. So on and so forth. But the thing with matrices is that you can't really divide them. And what's the number 1? Like what do we use as the number 1 anyway? So that's what we're going to be talking about here. And it's pretty interesting what the matrix world treats as the 1, what we call the identity matrix, what you can multiply by any other matrix, and you would get the same thing. So if we were to multiply this by the identity matrix, we would get this still, What the identity matrix is a square matrix that has, the kind of this diagonal pattern of 1s. So if it were to be a 10 by 10, there would be a 1 here, 1 here, 1 here, 1 here, 1 here, 1 here, so on and so forth. And the rest would be zeros. And you might think, well, what's the inverse or what's the identity matrix for a 3 by 2? Well, that's the thing. There is none. So identity matrices have to be square. And since the identity matrix has to be square, that also means that you can only find the inverse of a square matrix. Or at least that's what we're going to be doing. Only going to be finding the inverse of a square matrix, okay? So one of the ways that we're going to do that, one of the more difficult ways, math teachers always show you the more difficult way and then teach you the easier way after. So that's what we're going to do here. We're going to show you the harder way. But it's still easy in the sense that we know how to do it, that we've done it before. What we're going to do is augment this matrix, right? So we're going to attach solutions. We're going to augment this matrix with the identity matrix. So you can see I've augmented it here with that dashed line and put the 1, 0, 0, 1. And what we're going to do from here, we've never worked with this kind of matrix before. This is a 2 by 4 augmented, 2 on the augmented side. Like what even? Where do we even start, right? But this is going to be pretty simple in the sense that we want to flip these. We want this to turn into the 1, 0, 0, 1, and this. So just like we do when we're solving equations, we want to turn this matrix, our original matrix, into the identity matrix. And so that's what we're going to do. And then it's going to coincide with the inverse of whatever that original was. So while we turn this side into the identity matrix, we're going to simultaneously be turning this side into the inverse of our original. So you'll see what I mean as we go through it. Our first step here, our first step here is going to be to turn this into a 1. So how we're going to do that is by multiplying by 1/4. And remember our row operations, right? Remember that our row operations were, we could multiply by a constant, which is what we're doing here. We can swap 2 rows, or we can add or multiply a row by another. So what we're going to do is multiply by a constant. And that's going to bring us down here. We got 1, 7/4. And we're going to do the whole thing by 1/4. So then over here we've got 1/4 and 0. And the bottom row didn't change at all. 2, 6, 0, 1. After that, what I'm going to do is turn this number into a 0, because we're trying to get to that 1, 0, 0, 1 pattern, right? And so how we're going to do that is subtract 2 R1 from R2. So we take row 2 and we're going to subtract 2 times this row. So 2 minus 2 times 1 is going to be 0. 6 minus 2 times 7/4. That gets kind of ugly, but that's going to be 5/2. 0 minus 2 times 1/4. So 0 minus 2/4. So 0 minus 1/2. Well, that's going to be negative 1/2. And then 1 minus, okay, that's just 1. And then does the top row change? No, it does not. 1, 7/4, 1/4, 0. No, this isn't pretty, but yes, it's simple, right? We're just doing one step at a time. Simple mathematics, simple mathematics, simple mathematics. And we're going to continue on with that by multiplying. We're going to try to turn this number into a 1. So how are we going to turn a 5/2 into a 1? Well, we can multiply it by, yeah, this is a weird one to think about, right? So what we're going to do is multiply by 2/5. We're going to multiply by the reciprocal, right, to get that back to 1. So we're going to multiply the bottom row by 2/5 or divide by 5/2, because this divided by itself is 1, but dividing by 5/2 is the same as multiplying by 2/5. So we're going to multiply this whole row by 2/5. Top row doesn't change. Bottom row becomes 0, 1, negative 1/5, and 2/5. From there, we've got one more step, and that's to turn this into a 0. So the only way we can do that is by multiplying, because we can't just subtract numbers from a row, right? We got to think about our row operations. So we can't just swap them and fix it. We can't just multiply it by a number to get to 0. So what we're going to have to do is multiply this row by 7/4 real quick, and then subtract it, and then just bring it right back. So what we're going to do is subtract 7/4 R1, and that's going to be our new, R2, and that's going to be our new R1. And once that's our new R1, we have 1, 0, 0, 1 in our inverse matrix, so I'm going to move that over here. A little grand finale. We've got 1, 0, 0, 1, augmented with our final solution, which is 3/5, negative 7/10, negative 1/5, and 2/5. So hopefully that's legible. That's a negative 1/5. But yeah, so it seems like a pain, but really it's just it's just fraction multiplication repeatedly. And so it's nothing that you can't handle. It's just something you might not want to do, which sounds like a problem, not with the math. But luckily, there is an easier way to do these. So we'll take our original matrix again. 4, 7, 2, 6. And the formula, I know y'all love formulas. People love formulas. So the formula for this, the inverse, is going to be 1 over AD minus BC where this coincides with that. So this is A, B, C, D, A, B, C, D. 1 over AD minus BC, that number, times this new matrix, so from the original, D, negative B, negative C, A, equals your inverse. So this is your original. If we take these numbers and we assign them these letter values or whatever, these positions, and we use this formula, we will obtain the same answer. And I'll show you that real quick because it's a super simple and easy process. 1 over 4 times 6 minus 7 times 2. And then our new matrix is going to be D, so 6, negative B, so negative 7, negative 2, and then 4, because that swapped places. So this simplifies to 1/10, and we have our new matrix 6, negative 7, negative 2, 4. Once we multiply each of these entries by this constant, we have our final answer. And pay attention to what it looks like here. We've got 6 over 10, which reduces to 3/5. We've got negative 7 over 10. We've got negative 2 over 10, which reduces to 1/5. And we've got 4 over 10, which reduces to 2/5. So you see that both of these processes end up with the same answer. This is a process that you do know how to do on your own, based on the row operations and the augmented matrix practice that we had, or matrix practice that we had before. But this is definitely a more streamlined version and strategy here. And another thing, or one more thing to remember or to keep note of, is that if AD minus BC equals 0, then there's no inverse. And that is because 1 divided by 0 is undefined. And so that's just kind of a way to know if there's an inverse or not. So if you run into something that says, can you tell if there's an inverse or not? If so, find it. This is the way that you check. You check if AD minus BC equals 0. If it does, then unfortunately you can't go any further, can't do any more math, and you just know that there's no inverse. So thanks for sticking with me. Hope you've enjoyed these videos. Hope you learned something. Hope it wasn't too boring. Stick with math. Keep practicing this kind of stuff. And until next time. See ya.